Today's episode of the video is going to be solved examples under the square root of non-perfect square numbers. In fact, we give some few examples without solving them. Today's episode of the video is going to focus on solving some few examples, followed by more solved examples under the square root of non-perfect square numbers, because they are a little bit confusing. But if you take your time and follow it step by step, you will understand perfectly right here on Bash Maths Studio. Let's solve this example. Let's simplify the square root of example 1, of course. Our example 1 will be finding the square root of, let's say, 5. So if we have the square root of 5 without the scientific calculator or any other mathematical instrument, how would you be able to simplify this or find the equivalence value of root 5 in decimal fractions or simple fractions? We are going to, like I said earlier, we are going to use the long division method. So the solution is, it's very simple. We pick the square root of the 5 using the long division method. We have our 5. Now remember, with perfect square numbers, it is when you multiply a number by itself that yields a perfect square. So in the same vein, the secret in this is you look for a number if you multiply by itself, such that if you multiply that number by itself, it's either equal to the square root number or less. So for example, when you pick the square 2, square of 2 will give you 4. So the square of 3, this yields 4, this yields 6, and so on. You realize that the square of 3 yields 6, the square of 2 yields 4. Which one is closest and less to 5? It's 4, and therefore we are going to use 2, which yields a number that is closer to the square root of 5. So we pick 2 would be our divisor. So, and we get rid of this. Now 2 multiplied by itself, or the square of 2, will yield what? 4. That is 2 multiplied by 2 will give you 4. Then you subtract, of course. When you subtract, we get 1. Now you realize that we have to let 2 go into the new number, of which it is not possible. But with this approach, or the long division method in finding the square root of non-perfect square numbers, what you do is this: after finding this, you don't take the raw number, but you take the new number or the answer on top and double it, or you just add it to the previous divisor. So we have 2 plus 2 will give you 4. Then after, there is something you need to do. You can see that 4 cannot go into 1. So you are going to do as we've been doing in long division method, the same procedure. But here, there is always one thing to take note of. We are always going to place a certain number here. That is why I shifted 4 here a little, or 4 back a little. You are always going to put a certain number here. That same number should be up there. You add it to that particular number, such that when you multiply that same number by the new divisor you have gotten, the answer will be less than or equal to the dividend. I mean the number you are dividing. So with this, let's do a little bit of trial and error. So let's say this number cannot go into, so you will have to add 2 zeros, of course. You will have to add 2 zeros. Now can the number be maybe 1? If it is 1, it will just multiply by 1, and then you have 1 times 1 is 1, 1 times 4, so it's just going to be 41, so which is not the best to choose. Then let's pick another number, 42, and we multiply such that it will be either less or equal to 100. So let's pick and see. It's 4 and this is 8. So I think 84 is very close to 100. Now let's pick another number, 4, 3, and see if it will be less or very much closer than 4, 2. So 3 times 3 will be 9. 3 times is 12, which is more than the number. Hence we pick 4 2. So the number will be 2, and then the same number we put up there, just like we said earlier. So let's get rid of this. Now 4. What did we get? 4 2, we got 84. 4 2 2, so we got 84. So we multiplied, we got 84. Then we subtract. When we subtract, it's not possible. So as usual, you go to the left side and do borrowing. So we take 1 from here, 10. We take 1 9, we send it here. So this becomes 9. This becomes 10. This becomes 9. This becomes 9 10. So we subtract 4 from 10, we get 6. We subtract 8 from 9, we get 1. So the new dividend is 16. We move on. Now we still double this number. We still double 22. If you want to double the number, always neglect the decimal point. Or you just take the new number and add it to the divisor. So 42 plus 2 will give you 44. Note that there's going to be always a certain single number here. That same number will be put up there, such that if you multiply that same number that we're putting there by that new number, it is always going to be closer or equal to this number. And note also to be adding 2 zeros always. That is when all these figures has been taken care of. All the figures under the root sign has been taken care of. So now, which number are we going to put here, such that when we pick 4 4 times that particular number, or 4 4 that number times itself, is going to be either equal or closer to that number. So let's pick 2. 2 times 2 will be 4, 8, 8. So it's much smaller because this 1600. So let's pick 4 4 by, let's say 4, and see what happens. Might be more. So let's go by 3 first. So 3 3 will be 9. 3 times 4 will be 12. 2 remainder 1. 4 plus 12 plus 1, so 13. It's a bit closer. So when we pick 4, let's pick 4 and see. 4 by 16, 6 remainder 1. 16, 17, 7 remainder 1. 16. So of course it's bigger. It's bigger. So we consider that's which is more closer than. So the number we are going to put here will be 3, and that same number there will be 3. And when we multiply, we got 1 3 2 9. In fact, we can proceed on and on and on, but we have decided to leave our answer to 2 decimal places. Hence, the square root of, therefore, the square root of 5 is equal to 2 times 2.23 to 2 decimal places. So there are some few more examples we are going to solve under this episodes of the video. Thank you very much for watching. Please don't forget to subscribe. You can also comment there, and then you share for more episodes of these videos and more on our channel. Thank you very much. God bless you. See you in the next episode.